In this video, we're going to discuss the mechanism for acid-catalyzed imine formation. Here I have a simple ketone, methyl ethyl ketone, and methylamine. Under acid-catalyzed conditions, they can come together to form an imine. So let's see how this works. Well, first of all, it's important not to use too much acid in a reaction like this. If we had a high acid concentration, it would simply protonate the amine. We wouldn't have any free amine. We'd have an ammonium ion, and the reaction couldn't take place. So, but we're going to use just a small amount of acid. In fact, it's going to be a small enough amount of acid because we're not going to protonate the carbonyl. Instead, we're just going to have a direct reaction between the nitrogen and the carbonyl carbon, pushing the electrons out onto the oxygen. This gives us our first intermediate. The first intermediate here is a Zwitter ion, and what we need to do is, of course, get rid of that oxygen, so we need to move a proton over. So we're going to have the oxygen come around, grab one of these protons, and move the reform the nitrogen lone pair. So we transferred a proton. Now we want to get rid of the oxygen. So we do that by, of course, making it protonating it, so we can have a water molecule leave. Hydroxide is a terrible leaving group. We can't just kick out the hydroxide. So I need a proton. This is going to be our catalytic proton from over here. I'm going to use it now. Protonate the oxygen. So we protonate our oxygen. Now we can kick it out. But even now, the water molecule doesn't just leave, so we don't really want to form a carbocation. So what we do instead is we use the lone pair on this nitrogen to push out the water by forming a double bond. So here's our double bond, and then we kick out the water. So here we're all set up with those two arrows, and let's see how this goes. We're almost done. Here's our protonated imine. So we've nearly had our final product. The only step left is removing that proton, which we simply kick out and do our final step. And so here's our imine, and there's our catalytic proton given back. So this completes the mechanism. It's a general mechanism, can be done for all sorts of primary amines and ketones or aldehydes.